Everyone, good day. So in this topics, we are going to learn about how to control servo motor. So far we have learned about two motors, which are the DC motors and the starter motor. And you can see the difference how we are going to drive or control these two motors. So today we are going to learn the third motor, which is the RC servo motor, generic servo motor. So we are going to concentrate, just zoom down to the RC, which is a smaller version of the servo motor. And then we're going to look at the simulation and how it works. Alright? So what is servo motor? Servo motor is a small device that has an output shaft. So you can see here how servo motor looks like. Okay, it's based on the size, how good it to hold the load is based on the size and its scale. So it's actually a type of DC motor, and it's basically can rotate based on position. Normally, for the case you are going to learn about RC servo motor, the angle can be from 0 degree to 90 degree and 280 degree, right? And this is the one you can see. This is the RC servo motor, and this is the other version where you can do the the rotations more than 180 degree up to 360. So this is the thing that we are going to look at. All right, so more or less it's just like about the closed loop system, and for the servo motor this is the open loop, which is can turn up to 360 degree. Okay. And if you want to look at the control servo motor, this is very small version of that. It's very small, and you can just look at the spec later for this one, especially on the servo motor. When you want to purchase a servo motor, right, one of the spec that you want to check is about the torque that it can hold. All right, so this is, for example, the torque here is only 1.8 kg, which can hold. This is a stall position where this is the maximum one it can hold. So this is a what you call it, the stall top. This is the one. So for this case, right, this is going to be this particular position. Only 1 centimeter can hold the 1.8 kg torque, right? So if you have bigger RC servo motor, normally is going to have this one. Of course, the bigger the size it can hold, I mean, for example, the torque is much higher. In this case, it's around 30 kg. Right, so this is actually a rotation, so it can hold a particular one around that degree, 0 to 90 degree and 200 degree. Okay, how to control this one? Before that, we can see the usage of the servo motor, right? The difference based on the stepper and the DC motor. You can see the servo motor can be used normally in the toys or the shaft of the aeroplane toys. This is all the thing that can be controlled based on a few angles, right? Like 0 to 90 to 180 degree. So this is the method how to control this one. All right, so in between that one. So how to control is quite simple. All right, for the case that we are going to control is we are going to have a 3 position to control. We can start from 0 degree and then to 90 degree and 180 degree. The control will be based on the PWM that we generate. All right, so remember for the DC motor, we also control the speed by the PWM. But for the case right now, we cannot use the same PWM from the CCP pins go directly to the motor, because for this case of PWM, it cannot be supported due to the period is not is quite small compared to the one that we have over here. So for the case of servo motor, right, the period must be around 20 milliseconds. That will be the fixed value for the period. Okay, so the PWM, the pulse here, for the case of 0 degree, all right, so the pulse must be 1 milliseconds only, where the rest is going to be this is going to be 0 degree. Sorry, this is 0 voltage, 0 voltage. This is 5 volt voltage, and only 1 milliseconds can go up to 5 volt, and the other will go to 0 volt. Alright, so for the case of 90°, then it's going to be a bit more, which is around 0.5 milliseconds. You can generate this particular PWM, and same the period still that one. So in this case, right, this is 1 millisecond. Of course, this is going to be 19 milliseconds, where you can see the delay going up and down is 19 milliseconds. All right, and then the last one is, of course, this were quite simple. This is 2 milliseconds, and then this is going to be 18 milliseconds. Right, total up is going to be 20 milliseconds. So this is the case on how you want to drive this particular degree. All right, so we just have a look at the what you call that, the Proteus. You can see, you can just search for PWM servo motor, these 3 pins. Okay, the 3 pins here. Okay, you can see the connections here. There are 3 pins. The first one here, this is based on the physical pins, but for the Proteus, the first one will be power. This is going to be ground, and this is going to be signal generated as the PWM. We cannot use DCCP pins anymore because this is cannot support the period like 20 milliseconds. So we have to generate our own PWM to control this one. Alright, so this will be the case. Then you are going to look at the Proteus again, this one. So you can just use, for this case, I want to use the what you call that, here at center here. And then this one, ground. Okay, so you have this one. So just look at the spec of the motor. Now you can see this minimum angle is negative 90 degree, which is a bit different like this one. Minimum is 0, 180 degree. So we can change the spec for this one, go to 0. This is minimum 1, and the maximum angle is 180 degree. Alright, we just can just hit OK. So you have that particular position where the minimum will be 0 and the maximum will be 180. So we have to generate this 1 millisecond and 90 milliseconds. So in our program is quite simple. So we can just try to use one project. So here, just new project here. Next 20 megahertz. And then I'm going to save somewhere. Servo motor. So then okay, save. Next, finish. So of course the main program will start like this, void main, right? Okay, now look at your program. Here is RB0 port B, so I can start to set my port B as trace B is equivalent to 0B 00000000, because I want to send a signal out from this pin, which is this one. This is output for this pin. And then of course I have to do the while loop, because this is going to be a you have to this one, like for example, just open up this one, the curly bracket and close bracket first. Okay, so you are going to do this particular pattern, right? So going up and going down. Okay, so this is 1 millisecond, and then this is going to be 19 milliseconds. So 1 millisecond up, 90 milliseconds down. So you can just use delay Okay, if I don't want to use while one first for the first time, then it should be okay. Then we're going to look at this one, the results. So the first one is going to be port, right? Here. Then going up first, port B, right? Pin F0 is equivalent to 1, right? And then delay for 1 millisecond, delay ms 1 millisecond, and then it go down. Port B dot F0 is equivalent to 0, and then it has the delay of 19 milliseconds. Alright, now we just want to see this result. You just build this one. So this is semicolon. Okay, you have this one. Now you just go directly to this one. Go to your go up here, servo. This is the one, right? Just okay, and then you can just run this one. Now the first one is 0 volt, around 0 volt, which is correct, right? But to hold this one, right, you must have a consistent PWM like this. If you look at the results in your Proteus, you go for your oscilloscope here, right? Oscilloscope, and then you generate the signal P. Look at this one, and then run this one. You cannot see anything. Why? Because it happens only once, going up and down only once. Now you can see all 0 volt. Based on the program is going up once and then later going down forever. That's why you need to do the while one loop. Here in this case, you are going to do while one here, open curly bracket and close curly bracket. And then you are going to do the build and try again on your program. Now you can see the PWM. So one box over here will be based on this particular channel A. This is yellow color. So one box is equivalent to 5 volt here. Okay, so one box is 5 volt. So let's look at the period here. So you can change the period by changing this one. Alright, let's look at this one. Now you can look that if you change this one, you can see the full period of that. So right now I can just can we just how to do this one? I think so should be okay, this one. Okay. Alright, so this one, how many box here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So one box is equivalent to 2 milliseconds. So one box is 2 milliseconds, so total of 10. The period is total up to 20 milliseconds. So this is half of it, right? So 1 is 2 milliseconds and half of it is 1 millisecond. So it's proof that you have this type of PWM waveform that you can control this one. Alright, so let's try the next version of rotation. So let's look at the slides again. So 1.5 we cannot use the milliseconds at the moment, so we are going to jump to 2. You're going to jump to 2 milliseconds. So just go here. Now choose this one 2 and choose this one 18. Total up is 20 milliseconds. Build. Alright, so right now, yes, it's 180 degree. This one 180 degree, 2 milliseconds PWM over there. So let's try to calculate. So this is 2, the value will be 2 milliseconds. So we are going to try to make it here, position. All right, position here, just go here, and then okay, this is 1 volt, let's say 5 volt here. Okay, 5 volt, then you can arrange the waveform. All right, this is what, okay, now you can see here. So based on the two, okay, let's change this one right here. 1 2 3 4, 1 2 3 4, 4 for the horizontal, 4 box times 5 milliseconds is 20 milliseconds. 4 box times 5 is 20 milliseconds. So roughly, yeah, this is 1 box is equivalent to 2 milliseconds. So this is 1 2 3 4 5 6 7 8 9 10. Total will be 20 milliseconds, and 1 box is equivalent to 2 milliseconds. So we get back the value correctly, 180 degrees, so we can control this one. So how to change on the 1.5 milliseconds? You cannot use the milliseconds anymore. What you need to use is the help here. Just look at the delay. You have the delay microseconds. So microsecond is the one that you need to use, because now it's 0.5, right? 0.5. This is 0.5 here. 1.5. So this is going to be 1,500 if I'm not mistaken. Let's try to have the value written there. So this, instead of microsecond, is millisecond, go to milliseconds, microsecond here, sorry. So the first one is 1.5, right? So 1,500. Okay, and then this is going to be 17 1,500. This is going to be 20,000, 17, 18, 500. Okay, let's run this one. Just want to check. Oh, sorry. I have not yet. 1.5 milliseconds. Is it built? It's okay. Yeah, it's 90 degree. So right now, you can calculate here 1.5. Let's say, for example, here, this is 1 box is equivalent to 2 milliseconds again. So the full period is 1 2 3 4 5 6 7 8 9 10. Full period is 20 milliseconds. And what do you call it? Let's check this one. Roughly is not 2. This is around 1.5. So it's very clear. You can look at the waveform here. It's around 1.5. So then you can control up to 90 degree. So it's quite direct, the control system here. You cannot use any driver. You don't use driver to control this one, but you can just directly give a PWM signal generated from the PIC, and you can control the movement or the angles of the servo motor. So that will be the difference on the motor that we have before, like the stepper and the DC motor. So you can do the comparison on all of the 3 motors and try to find out the best solution if the question is asking about how you are going to design based on certain functions. So you have to select which is the best motor which can suit well on the task that you want to do. Okay, that's all for the servo motor. Thank you very much.